Hi students, this is Mr. Liao. Today we are going to talk about the last transformation, which is rotation. Today's lesson is about how to graph rotation. So let's first recall some information that we should know by now. First, clockwise rotation. That means it's going the same direction as the clock, which is the direction in B. The 90 degree, that is a little square thing, so that's 360 degrees means it's a full cycle, so that's gotta be D. 180 degree is a straight line, so right here, that is A. 270 is actually 3 quadrants, so that is gonna be F. And 6, of course, is the opposite direction as B, and that is E. Now let's talk about rotation. Rotation is a transformation that turns a figure about a fixed point. And the rotated shape is the image. For example, the Earth rotates around the Sun, and in that case, we would think the Sun as the fixed point. This fixed point, there's a mathematical name. It is actually called center of rotation. But it's just because it's a fixed point, we are just going to use that to describe it. Rotation is a rigid transformation, and that's what we have learned before. It is a rigid transformation, meaning the shape and the size does not change. Just kind of like location-wise, it's going to change. Thus, size, perimeter, and area are preserved. However, for rotation, orientation would typically change. And that's how we actually tell rotation apart from other transformations. When we say orientation, it's like, for example, you have like this shape, and generally that little angle is pointing up. If you rotate like to the right, for example, this way, that's going to give you a shape like that. Then this is actually pointing to the right. Or if you actually rotate down, then it's going to point down. So orientation would change. That's what it means. And we will use perpendicular lines to help us with rotations of 90 degrees because, of course, 90 degrees is related to perpendicular slopes. And that's something we actually have learned in the reflection lesson. As for a description for rotation, there are quite a few things. We need to include the fixed point. In this case, it could be the origin or any point. We also need to include the angle that is rotating. And we also need to indicate which direction it is rotating. Angle-wise, we are dealing with the common ones, which would be 90 degree or 180 degrees. It could also be 270, but it's not very common. And direction, we are including clockwise or counterclockwise. So first little question for you to think about, why don't we need a direction for 180 degrees? Well, because if something is pointing like that, and you rotate clockwise 180 degrees, it's just going to point down. Or if you rotate the other way 180 degrees, that's going to get you the same thing, which is why direction does not matter. So when we actually write the description by ourselves, we do not need to include the direction. It's more when we're actually seeing a question that says, for example, 180 degrees clockwise, we do need to understand what that means. Next little question, why don't we need a 270 degree rotation? So for example, if you are rotating, let's say it's right here, if you are rotating 270 degrees clockwise, that's going to end up right here. And it is the same as rotating 90 degrees counterclockwise. Or let's say if you are just rotating counterclockwise to begin with, that's going to be right here. And that would be the same as rotating clockwise of 90 degrees. That's because 270 is actually related to 90 degrees since they add up to a full cycle, which is 360, so that we can just use the opposite direction to kind of describe. That's why we do not need a 270 degree rotation. Now, in your notes, you may see 90 degree rotation next, but we are actually gonna flip the page and talk about the 180 degree rotation first, since that is easier than 90 degree. So let's go ahead and have a look at the 180 degree rotation. To rotate 180 degrees, first step, you are going to connect a point on the pre-image with the fixed point. So let's actually try to do that in example 5. Let's say we're going to start with point W, and this is the origin, it's around the origin, so connect with the origin. And step 2, we are going to extend the line the same distance past the fixed point to get the image point. Here, we are not exactly going to calculate how long it is, but we are going to use the little squares in the grid to help us. This little line I just draw is actually a full diagonal of this little square. So that means all I need to do is extend another full diagonal of a little square. And that's going to give us a point right there, W prime. And here's the thing. If you are doing this question on the paper, you may actually end up with quite a few lines. It's totally fine if you would like to erase your helping line after you're done with a point. So I can choose to erase this. Just leave the point that I got. Next, I'm going to deal with V. So let's connect. I'm going to use a different color. Connect V to the origin. V is down 3 over 4 away. When we need to extend it, we also need to do down 3 over 4. So there's my V prime. And same thing, after we're done, we can choose to erase all of these lines. And lastly, we have point U. And let's see, here it is, connect U to the origin. And that actually is 2 up, 4 away. So when I extend it, I'm going to go the same direction, 2 up, 4 away. And there's my U prime. I'm going to keep that one, but in the end, I am going to need to connect all of these 3 points to generate my actual rotated shape. And afterwards, I'm going to actually draw these lines just so that people can see clearly. V connect and V connect. There we go. That's example 5. You can pause here to try example 6. Now that you have tried example 6, we can have a look. Rotate 180 degrees around -1, 1. This question is not about the origin anymore. It is actually about this point right here, -1, 1. So first thing, we are going to connect, and we are going to extend. That is clearly a 1/2 square away, so extend the same amount. That's going to get me R prime. Next, T or S, either one. S coming out to R, extend the same direction. It is a 2/1 away, so we're going to extend 2/1. That is going to give me my S prime. Oh, actually, I just got the points wrong. The point is actually -1, 1, so I'm going to need to connect right here. So it is not 3/2, it's actually a 3/3. So extend 3/3 right here. There's my actual S prime. Next, T and T prime. That would be right here, connect. That is 3 up, but it's 5 over, so I'm going to extend the same thing, 3 down, 5 to the left, which is slightly outside the graph, but that's my T prime. Lastly, U connect to the line, and that actually is a 2/5 away. So 2/5 away. There's my U prime. Lastly, connect everything. T prime to S prime, T prime to U prime, U prime to where's my, oh, there's one point I actually forgot. No, R is right here. There we go. Connect. Okay, so there's example 6. Now we're gonna go back to actually talk about the perpendicular stuff. So flip back to the previous page. We are going to talk about how to rotate 90 degrees. We're going to involve some things that's very similar to the reflection lesson. We are going to need to use the same distance and the perpendicular slope. Before we actually move on to the actual example and steps, let's clarify something about the slopes. If you have slope for, like say 1/5, that you have 2 different ways to describe it. It could actually be up 1, right 5, and that's typically we say over 5, or this is the same as a -1 over a -5. So we could also say that is down 1, left 5. Or let's say if you have -2 over 3. That also 2 different ways to see it. You can also rewrite that to be 2 over -3. So it could be going up 2, then -3 would be left 3, or then if it's -2, that would be down 2, and then right That's something we need to clarify about the slopes because we're going to depend on slopes to do this part. And I know there are other ways that we can work with these rotations, but I would like to teach it this way to separate by 90 degree and 180 and use this method because it's going to benefit us in the next lesson. Now the steps. First step, connect a point on the pre-image with the fixed point and find the slope of this helping line. Second step, we're going to draw a line through the fixed point that is perpendicular to the helping line. Next step, we are going to generate the same distance on this line we just draw. And we are going to need to use the little rectangles to help us. So for example, the diagonal of a 2 by 3 is the same length as the diagonal of a 3 by 2. Lastly, we just need to repeat the process and for every single point and then connect to get the new shape, which is the image. Now let's have a look how this works in an example. Example 1. First, let's start with line point C is around the origin, so we're going to connect C and the origin. Since eventually I will allow you to actually erase the helping lines, that's why I'm going to need you to write the slopes to show me the work. So for point C, this current line that we just draw, the slope is a negative 2 over 1, which is a negative 2. That means the slope that I need is going to be a positive 1/2. When I say I need, that means I'm trying to find the perpendicular slope. So perpendicular slope is right here. 1/2, so up 1 over 2, up 1 over 2, down 1 over 2, and down 1 over 2. So we are going to, that's actually down 1 over 2. We are going to connect everything. That is after step 1 and step 2. Now we are going to need to generate the same distance. If you look at this little shape that we have, this little shape, the line that I draw is actually within a 1 by 2 rectangle. It's a diagonal of a 1 by 2 rectangle. I can have my rectangle this way, or let me draw it on the bottom. I can have my rectangle this way, or I can have my rectangle that way. And the top or the bottom, left or right, they're all going to be the same. So all I need is the same distance of a point that's on this line we just generated. So you can clearly see we can't do 2 by 1 again. We also can't do 2 by 1 here. There's no other way. The only way for you to do is actually use the grid. So right here, a 2 by 1 is actually a 2 by 1. So that is my possible potential point C prime. But as you may notice, that's just one of them. I can also go 1 by 2. And that means this is also a potential C prime. Now, here's what how we're gonna decide which one to keep. The question said clockwise. So I'm gonna need to turn clockwise. That means this is the actual point I'm going to keep for my C prime. And when you are done, you can totally erase all the little helping lines. Otherwise, you may have too many lines. That's gonna make things confusing. So I'm going to erase all of these and only leave the point that I need, which is C prime. Let's go through that process again. For D, connect with D. For that line, the slope is actually 3 over 2. We need the opposite reciprocal, which make it negative 2 over 3. And again, this is the same as a 2 over negative 3. They are the same. So now it's time to generate. From the origin, I need negative 2 over 3. So down 2 to the right 3. Or I can do 2 over negative 3. So it's up 2, left 3. And there we go. That's our perpendicular line to D connected to the origin. And as you may notice, this is a 3 by 2 little rectangle. I can have a 3 by 2 rectangle right here. So that means this point is going to be my D prime. So I can erase everything else that I actually do not need. All of these. Lastly, we have point E. Whenever we have a point on the axis, that's going to make things a bit easier. So because from one axis to another axis is always going to be 90 degrees. That's why if we're rotating E clockwise, it's just going to end up right here on the y-axis as an E prime. Lastly, we just need to connect the shape. That is, oh, I actually had it wrong. That's not my C. That's my C prime. That's my D prime. That is my D prime connect to E prime. And that is example 1. This is quite a bit of process, but again, I don't need you to show me all the helping lines, but this is how you show me the work. Finding the original slope and find a perpendicular slope. Next, example 2. Around the origin again, x is easy, and if it's clockwise going that way, so x prime is just going to be right there. Everything else, let's start having a look. First, starting with w to the origin, w to the origin, that's up 4 over 2. The reason I'm doing an unsimplified fraction is because I can tell this is actually a diagonal of a 4 by 2 rectangle. That's easier for me to recognize what it is. So I'm going to keep it that way, and we can do the opposite reciprocal, which is the slope, which is the perpendicular line. So it has to be negative 2 over 4. So let's generate the line. Negative 2 over 4 means down 2 to the right 4. And if we're rotating clockwise, that is clockwise. So that means we are actually keeping this point as my W prime. So when we work on this question, you may have noticed that I'm not drawing every single line anymore, because I can keep everything kind of with the slope and keep them in my mind. And then I can actually find the new point. So let's try another one. I am going to erase everything so far. So next is, let's do point V. For point V, it is up 1 over 5. Again, up is vertical, and over, whenever we say over, it means whenever we say over something, it's got to be to the right. So that slope is actually 1/5. That means the perpendicular slope that I need is negative 5 or negative 5 over 1. So here's the connection from V to the origin. Negative 5 over 1 means down 5. The over means to the right. Or I can do, this is also the same as a 5 over negative 1. That's up 5 to the left by 1. So there is my perpendicular line right here. So I can decide which point I am going to keep. In fact, if this is clockwise, that is the point I'm going to keep, which is V prime. Now I can erase all these little extra lines. I do not need them to generate anything. So there it is. Back, last one, we have Y. Let's connect Y to the origin. And for point Y, that is clearly a down 2 to the right by 1. So it's negative 2 over 1. We need a positive 1/2. In that case, starting from Y, positive 1/2 means up 1 to the right by 2 or down 1 to the left by 2. There's my perpendicular line, and they are actually, in fact, 1/2 rectangle away. So I'm going to use one of these points. Clockwise would mean the point is right here. There's my actual Y. Oh, wait. It is, I draw the line in the wrong place. It's up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2 is actually right here. There we go. So it's either going to be this point or that point. Clockwise, that is going to be this point as my Y prime. I can erase everything else that I do not need. There we go. Now I can actually connect everything. X prime to Y prime to V prime to Y prime, W prime to V prime to Y prime, and Y prime back to X prime. That is example 2. Hopefully that clarified things up. We're going to do 2 more examples. Next, example 3. This time it's around the point -1, 1. I highly recommend you pause the video right here so you can try example 3 and 4 by yourself, and then you can come back and check your answers. Whenever we actually do it around a different point, the process does not change. It's just we are going to need to connect everything to that point. In this case, the point is 1, 1. So let's start with point U, connect. That is a 2 by 3, so U is actually down 2 over 3. That means the slope that I need is a 3 over 2. So here it is, up 3 over 2, or down 3, left 2. Because again, this is the same as -3 over -2. So there's my perpendicular line. We're rotating counterclockwise, so it's got to go this way. So that is my. I'm going to erase everything. Next, T is already on the axis. So I'm just going to, well, actually not quite on the axis. So I do need to connect it. My T is actually going to be an up 1 over 2. So that is 1/2 as the slope. That means my new slope is going to be a -2. -2 means -2 over 1. So it's down 2 over 1 or up 2, left 1. There is my perpendicular line right here. And I need counterclockwise. So from this point, counterclockwise, that is going to be my T prime. Now, time to erase everything so I don't have anything that's distracting me. Next, S. Let's do S, connect them. That is up 1, 2, 3, 4, 5. So my S is going to be a 5 over 2. That means the slope I need is a -2 over 5. So from this point down to the right 5. It's going to be slightly out, or up to left 5. It's going to be right here. You should be able to tell already. It's counterclockwise, so from here it's got to go that direction, which means this would have to be the point that we keep, S prime. Erase everything else. Lastly, we have V prime. Connect V with the point. My V is going to be may have overlap. My V is going to be up 1 over 5. So the new slope that I need is -5 over 1. So from this point down 5, 1, 2, 3, 4, 5. Again, the over 1 means to the right by 1. Or up 1, 2, 3, 4, 5, left 1. There's my perpendicular line. I need counterclockwise, so it's got to go this direction. That means I'm keeping this point V prime. Lastly, connect everything. U prime to T prime, T prime to S prime, S prime to V prime, and V prime back to U. That's example 3. Last one, example 4. This time, I'm just going to do the process and let you think through. T, the point is right here, connect. That is 3 over 2, so the slope I need is -2 over 3. From this point down 2 over 3, or up 2, left 3. And it's counterclockwise, so that means I need to go that direction from this line. This is going to be my T prime. Okay, next. S. So S currently connect is going to be down 2 to the right 3, so it's -2/3. That means I need 3 over 2. So up 3 over 2, or down 3, left 2. It is counterclockwise, that means I need counterclockwise, so this is the point I need. That is actually my S prime. Erase everything else. Lastly, U prime, U, connect. My U is up 2 over 5, so 2/5 away. That means I need the slope of -5 over 2. So -5, 1, 2, 3, 4, 5. Then over 2 is going to be right here a point, or 1, 2, 3, 4, 5. That is going to get me left 2 right here, a U prime, because this is the counterclockwise. Erase everything else. Lastly, we just need to connect everything. Connect U prime to T prime, T prime to S prime, and S prime with U prime. That is example 4. So 90 degree does take a bit of time, but I am trying to slow down to make sure I understand the slopes. Hopefully you do. And that is everything for the first lesson of rotation. Thank you.